In today's lesson, we're going to discuss some different proportions that appear in certain situations, specifically in triangles. First concept we're going to talk about is called the Side-Splitter Theorem. Okay? And what the Side-Splitter Theorem states, if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So in this case, SU is parallel to RV, and SU is intersecting the other two sides of the triangle. So that means that these four pieces are proportional. So if I need to solve this proportion, I can set up my proportion x over 16 equals 5 over 10. Okay, next we have a corollary to that, which I like to call the three parallel line rule. If we have three or more parallel lines intersected by two transversals, which are these lines right here, then it divides each of these pieces into proportional sections. So in this case, I can set up a proportion A over B equals C over D. And last we have the triangle angle bisector theorem. If an angle of a triangle is bisected, okay, then the line or ray that bisects that angle will split this triangle into proportional pieces. So if I label these W, X, Y, and Z, I can now set up a proportion to figure out any missing values. Okay? So let's try a couple of examples. In this case, this would be the side-splitter theorem, because we have the parallel lines, and that's going to divide all these pieces into proportional lengths, okay? So I can just take my proportion right off the diagram. I'd go y over 6 equals 12 over 10. And then I'll cross multiply that, okay? So that's going to be 7.2. You could also set it up, for instance, I can go y over 12 equals 6 over 10. Or you can do it the other way. 12 over y equals 10 over 6. There's a bunch of different ways you can set that proportion up. Either way, when you cross multiply, you're still going to get 7.2. Okay? This next example, this is the three parallel line rule. So we have three parallel lines intersected by two transversals. So that means the transversals are now split into proportional lengths. So my proportion here would be 4 over 6 equals 5 over x. And I can cross multiply and get my answer for x would be 7.5. And last we have the triangle angle bisector theorem. So we have an angle of this triangle RSP is bisected because it's marked congruent. So that means all four of these pieces are now proportional. So I can set my proportion up just as it is. 8 over x equals 5 over 6. And then I can cross multiply that. Okay? And when we cross multiply that, we're going to get 9.6. That's it. That concludes the lesson on proportions that fall in triangles.